Hello dear students. So, in continuation with our understanding of various atmospheric thermodynamical processes and the formation of clouds and atmospheric stability, we are discussing the formation of cloud droplets or how droplets of ice will also exist inside the cloud. Okay. So, we have seen what kind of stability permits the air to be uplifted resulting in the condensation. So, we will try to understand how the condensation will grow a particular droplets to the sizes of cloud droplets or to the sizes of rain droplets. So, in the last class we have seen that once ice crystal is formed, in its direction or in its movement towards the ground, it will collide with several other tiny droplets, and in some clouds ice crystals might collide with supercooled liquid droplets, water droplets. Upon the contact, the liquid droplets freeze into the ice and stick to the ice crystal. So, this process is called as accretion or riming. So, what you will understand is that tiny droplets of supercooled water will get stuck onto the ice crystal, and thereby the ice crystal will grow in size. So, the icy matter that forms in this process is called as graupel or snow pellets. This is mainly called as the snow pellets, right. So, let us say in colder clouds, the ice crystals may collide with other ice crystals and fracture into smaller ice particles or tiny seeds which freezes hundreds of supercooled droplets on contact. So, when these ice crystals break, small ice crystals will form and they will start collecting the tiny droplets of supercooled water, and in this process will allow the ice crystals to grow even more further, right. And that was something about the accretion. And in addition to that, as the crystals fall, as they continue their descent towards the lower altitudes, they may collide and stick to one another, forming an aggregate of crystals called as snowflakes. So, this is the journey from a simple ice crystal to what is called as the snowflake that you see when it snows, right. So, this process is called as the aggregation. This process is called as the aggregation, and this is the typical, let us say, this is how a snowflake will look like. So, this has a distinct shape actually, right. Now, so it is evident by now is that cloud is a collection of highly tiny droplets of water. These droplets are typically of the order of few micrometers in size, and as long as the cloud is stable, it will not lead towards the precipitation, or so the process is from a vapor condensing onto the top of a cloud condensation nuclei, which will result in a very small or very tiny droplets. When these tiny droplets by any means or methods grow several hundreds of times, then you will realize they are called as the rain droplets. These rain droplets are substantially larger and they are heavier in the sense they get attracted by the gravity and they will descend towards the surface, right. So, the process of, let us say, making the precipitation artificially is called as the cloud seeding. So, to inject let us say, or to seed a cloud with small particles that will act as nuclei, so that the cloud particles will grow large enough to fall to the surface of the earth, and also can also be called as the precipitation, is generally called as the cloud seeding. So, the cloud seeding is the process in which you inject or very small or cloud condensation nuclei type of particles into the cloud, so that they will act as surfaces on which tiny droplets of water will condense and grow into the larger rain droplets, right. So, the first experiments of this sort were conducted in early 1940s using dry ice, where the dry ice itself used to act as surfaces for condensation, right. Later it was realized silver iodide is also used today because its structure is similar to that of an ice crystal. Basically, it's a surface on which you want the vapor to condense, right. Natural seeding is what sideroform clouds lie directly above or lower clouds deck. So, ice crystal descend into the lower clouds. So, this is where the cloud seeding is mainly targeted, right. And so, the main outcome that is expected out of this process is the precipitation. right. So, this is how you will seed the clouds, let us say, where natural seeding is occurring by the cirrus clouds, which are, let us say, this is the cirrus clouds, right. So, natural seeding by cirrus clouds may form bands of precipitation downward of a mountain chain. So, this can the cirrus clouds can themselves act as mechanism to provide tiny crystals of ice into the cumulus clouds. Thereby, they are naturally seeding this particular clouds which already have some vapor in it, right. Now, when you talk about precipitation, what is precipitation? The basic idea of precipitation is when a small cloud droplet grows into a rain droplet at a sustainable size. When it crosses a sustainable size, this rain droplet will start moving towards the ground bound by the gravity. When this rain droplet reaches the surface, you call it as precipitation, right. So, precipitation can be of many different types or many different forms, let us say. So, the main or major form of precipitation is the rain, which can be a drizzle or which can be a virga, which can also be showers. And the other form of precipitation, which is of course not in the liquid phase, rather in the solid phase, is the snow. Snow can be is not a single type of precipitation. Within the snow category, there are several other types of precipitation, let us say snow grains or snow pellets, fall streaks, flurries, squalls, blizzard. All these are precipitation in the form of let us say ice or ice crystals or snowflakes, etc. Right. And another form of precipitation which probably won't reach the earth is sleet or freezing rain, or the most dangerous form of precipitation is hail or hailstorms. So, we will try to understand how these different forms of precipitation are different physically for the physical appearance, or how they will what are the various conditions during which this type of precipitation may actually occur, right. So, let us say rain. So, rain is the most known form of precipitation that we see very often, right. So, let us say the falling drop of liquid water that has a diameter equal to or greater than 0.5 millimeters or 0.02 inch can be classified as rain. So, when the downward movement of water in the sizes of more than 0.5 millimeter, then you call it as half a millimeter is generally called as rain. So, what is drizzle then? So, drizzle is drops which are too small to qualify as rain. So, you put the scale as 0.5 millimeter. So, any precipitation whose constituents or whose droplets are more than 0.5 millimeters are classified into what is called as rain. So, something that is less than this limit generally classifies to be what is called as a drizzle, right. And what is virga? Raindrops that fall from a cloud but evaporate before reaching the ground is called as virga. So, if you imagine your cloud bottom to be at, let us say, 8 kilometers or 9 kilometers, then whatever the precipitation that results out of this cloud must reach the surface. Only then you call it as rain, if it is of a typical size. But if it rains but it never reaches the earth, you call it as virga. Shower is intermittent precipitation from a cumuliform cloud, usually short duration but often heavy intensity, right. So, this is what is called as a shower. Acid rain are the ones in which rain that is intermixed with gaseous pollutants. So, gaseous pollutants exist in the atmosphere, but if your H2O precipitation is intermixed with these gaseous constituents or gaseous pollutants, then you call this type of precipitation as acid rain, right. So, this is how it looks like. So, these clouds are, of course, they are precipitating. I mean, the cloud is unstable. So, the droplets, very tiny droplets are of course growing to large droplets to be able to be pulled by the gravity. But the thing is, the precipitation is too less that it is released, this precipitation is released, but this precipitation that is being released like this is of course not reaching the surface. So, this type of precipitation is not going to make to the surface. So, this is called as virga, right. So, that was something about the precipitation in the form of liquid water. When you talk about precipitation in the form of solid H2O, the different phase, a solid form of precipitation is composed of ice crystals which are in a complex hexagonal form. The ice crystals are in a complex hexagonal form. So, basically precipitation in the form of solid is generally referred to as snow. So, much of the precipitation reaching the ground actually begins as snow. Okay. So, within this particular class of precipitation, there are several other let us say forms. So, fall streaks, ice crystals and snowflakes falling from high clouds, high cirrus clouds. So, in our cloud classification, we have seen that clouds which are very high in altitudes are generally known as cirrus clouds. So, ice crystals, fall streaks are the ones which represents the ice crystals and snowflakes falling from very high cirrus clouds. So, they behave similar to virga, fall into drier air and disappear before reaching the ground. So, they fall into the drier air. So, where there is a lack of moisture, so these ice crystals will be evaporated, and this they evaporated in the sense they will be melted. So, now the point is the amount of water is lost into vapor again. So, they will never reach the earth. So, this is similar to virga in the sense that there is precipitation in the solid form, but the precipitation hardly reaches the surface. Flurries are the ones with, let us say, light snow showers that fall intermittently for shorter duration, light accumulation. So, these are very light kind of snow events, right. Squall is more intense, snow shower brief but heavy snowfall. And blizzard is the most rare occurrence, or is the most severe one in the form of precipitation in solid form. Blizzard is severe weather condition. So, temperatures will be very low to be able to cause this kind of an event. So, low temperatures and strong winds greater than, let us say, 30 knots per second, bearing a great amount of falling or blowing snow. So, this kind of severe events of snow are generally called as the blizzards, right. So, this is just an example where ice crystals are kind of trying to precipitate, but they will never reach the surface. So, this is the type of cloud here is cirrus cloud. So, this is what is happening. So, this is the precipitation that is trying to reach the earth, but it is not making to the earth anyway. So, what do you call this as? This you call as the fall streaks. So, these are the fall streaks, right. So, these are what are called as the fall streaks, right. So, this is how a typical snowflake will look like. So, most common forms of snow. So, this forms out of agglomeration, right. And the other form of precipitation is sleet and freezing rain. Sleet is a type of precipitation consisting of transparent pellet of ice 5 millimeter or less in diameter, right. So, you call something else when the size is more than that, but below that particular size you call it the ice crystals, which are typically of the order of, let us say, diameter of 5 millimeter or less, are called as this is sleet. So, freezing rain or drizzle, let us say rain or drizzle that falls in liquid form and then freezes upon striking a cold object on the ground is called as a freezing rain. So, it of course arrives in the liquid form, but it freezes upon hitting an even cooler or colder object, right. Rime is an accumulation of white or milky granular ice formed when supercooled cloud or fog droplets strike an object whose temperature is below freezing. So, you have liquid water, but when it touches even colder surface, you get to see what is called as the rime, right. So, let us say if you look at the vertical temperature profile, so you have to understand. So, wherever the temperature is more than 0 degrees Celsius, the freezing point of water, it is just that water will be existing in the liquid phase in that particular point, and when the temperature is becoming less than 0 degree Celsius, automatically you will expect freezing and you will expect a lot of snow to be existing at that particular temperature, right. So, let us say, so this is the temperature how it is varying. So, temperature is increasing with respect to height up to a particular altitude, then it is decreasing. So, whatever it is, if you put the 0 degree centigrade mark here, so this region is the region which is kind of conducive for the water to exist in the liquid form, as the temperature is more than 0 degree Celsius. So, water cannot freeze here, but anything which below this, let us say this region and this region are the ones where the water will exist in the ice form. So, even if a snowflake which is falling from a particular type of cloud is in the solid phase, when it falls due to the virtue of its weight or the mass, when it reaches this area where water is more likely to be in the liquid phase, you will see that the snowflake will melt and it will form a rain droplet. Once it crosses this region and enters a region where the temperatures are sub-zero, it automatically freezes again, and then you will see the sleet. So, sleet forms when a partially melted snowflake or a cold rain droplet freezes into a pallet of ice before reaching the ground. This is the basic understanding of the formation of sleet, right. So, rime is an accumulation of, so this is accumulation of forms of rime on tree branches as supercooled fog droplets freeze on contact with the below freezing air. So, the atmosphere, the ground is itself is very cold or below freezing temperatures, right. So, so this is where you see a heavy coating of freezing rain during this ice storm caused tree limbs to break and power lines to sag. So, this is all the water has accumulated on these power cables, and it has crystallized or it has formed into ice. So, due to the weight, you see the wires are heavily sagged, right. So, now we will list few important temperature profiles that are required for the formation of, let us say, formation of snow. So, what you see here, the vertical line that you see is 0 degree Celsius mark. That means this is the freezing point of ice. Let us say if you take a location in the polar region, what you will see is the temperatures are sub-zero everywhere at the ground or at the 10 kilometers or at 15 kilometers, whatever it is. So, the temperatures are always, I mean all of the heights, the temperatures is sub-zero. So, if in such a condition, if you develop snow or ice crystals at a particular altitude, and these ice crystals build up to a sufficiently larger amount of mass so that they travel towards the ground, then automatically as it travels, there is nothing which can cause these ice crystals to get warmed or to melt. So, as a result, finally when it reaches the surface, you will see only snow, but not rain. So, that is because the temperatures are have always been less than the freezing point temperatures, right. Now, so vertical temperatures profiles associated with sleet. So, let us say you have 0 degree Celsius vertical line, and now if the temperature of the atmosphere is varying like this. So, at the ground the temperatures are very less, and as you go up the temperatures are increasing, and they will increase to a particular height, let us say, and then they will decrease again, but they are crossing the 0 degree Celsius mark at 2 points. Now, if you imagine the cloud bottoms to be existing at these heights, and if snow develops to a sufficiently large mass and it starts traveling towards the ground, here at this point it encounters a region or a temperature which is more, in the sense the temperature will melt the snow, right. Now, the snow will again cross that point and will again start freezing. So, partially froze water will eventually make it to the surface, then you can call it as the sleet, right. Now, vertical temperature profile associated with the freezing rain. So, right. So, what you see here is that the temperature 0 degree Celsius temperature is very is the vertical line, and the temperatures at the ground are not very low in comparison to the earlier case that we have seen. The temperatures are slightly less than the freezing temperature, but the point of origin of precipitation is allowing only ice to be precipitated. It gets heated to this particular point when the temperatures are very high, but when it is again traveling towards the ground, the difference in the temperatures won't allow all this liquid again to be solidified and again to be frozen into ice. So, as a result you will see Rhine which is which we call it as the freezing Rhine, right. And similarly another profile of temperature vertical temperature profile associated with Rhine. So, this is where you see the temperature is never below 0 degrees Celsius, only at this point it is below the 0 degrees Celsius. So, you see that if the precipitation at a particular height 10,000 feet has resulted in the formation of snow which is traveling downwards, once it crosses the 0 degrees Celsius limit, then all the ice melts and it will create the Rhine. Now, this Rhine has never been given the opportunity to again freeze throughout its vertical descent, right. So, that means that at the final outcome you will get see only Rhine. Right. Now, hail is a totally different process in the sense hail is one occurrence where you see large ice crystals which are very large in comparison to a typical rain droplet or a typical ice crystal. So, hailstones, they are generally referred to as hailstones in the sense that you see them to be very large and very impactful or very harmful for the life or for any property, let us say. Hailstones are the pieces of ice either transparent or partially opaque, ranging in size from that of a small pea to that of a golf ball or even to the size of a baseball, right. So, they are produced in cumulonimbus clouds when grape, large frozen raindrops or just about anything insects act as embryos that grow by accumulating supercooled liquid droplets. So, anything, any smallest entity, if it starts accumulating water or if it starts accumulating the water vapor, subsequently as it becomes larger, it comes in contact with even more amount of tiny droplets which will just get stuck onto the surface, and because the temperatures are already freezing, so they will just again become ice. So, as a result, this small insect or the small gropel will act as embryo for the creation of this particular object. So, what do you see at the end of it? You will see a huge ice crystal, typically of this can be as small as this and this can be as large as this or even larger than this, right. So, this is the typical size that many reports have confirmed the hailstone can grow up to. Right. So, what has been seen is that golf ball size hail has remained aloft for between let us say 5 to 10 15 minutes. So, they exist within the cloud. So, there is a strong vertical updraft in the cloud which makes this, which prevents this crystals falling to the ground. They will hold it as long as they could, but when the weight of the hailstone gets too high or overcomes the updraft, it has to come down and it has to fall on the ground, and then it can cause a lot of damage depending on what it falls onto, right. So, hailstones begins as embryos. I mean, embryo is, what is embryo? Embryo is the smallest entity which gives birth to the hailstone, right. Hailstone begin as embryos. Usually the ice particles itself, they are not anything else. It can be an insect, it can be a populent, it can be a pollutant particle, soot, anything that remains suspended in the cloud by violent updraft. So, this vertical updraft is what makes these type of embryos available in the cumulonimbus cloud. So, you see this hugely developed, vertically developed cloud is generally known as the cumulonimbus cloud, and this cloud is the one which can bring every natural calamity to a particular point. It can bring rain, it can bring hail, it can bring thunderstorms, it can bring heavy amounts of lightning, everything, right. So, what you see in this figure is the updraft. So, this is the vertical movement of air which of course creates the cloud in the first place. With this strong movement of vertical air allows the hail or allows the embryo to be present at a particular altitude. When the updrafts are tilted, the ice particles are swept horizontally throughout the cloud. So, they are swept like this throughout the cloud, right. Along their path, the ice particles collide supercooled liquid droplets. So, this is the freezing level. That means the temperature here is 0 degrees Celsius. Anything above, water has naturally a tendency that it will exist in the ice form. I mean ice, these are ice crystals, but here what you see, they are the water droplets. So, above this 0 degree Celsius, the temperature is of course decreasing with respect to height in this particular altitude. So, as the hailstone is traveling horizontally, not just in a horizontal line as such, but the overall movement is, the drift is in the horizontal direction. So, in that process it comes across many different small ice crystals. So, it will start accumulating all those ice crystals on its surface, and it starts growing. So, this triggers the growth. Along their path, the ice particles collide with supercooled liquid droplets, which freeze on contact. The ice particles eventually grow large enough and heavy enough to fall towards the ground as the hailstones. So, the most important thing that you should remember is that vertical updrafts will still prevent the hail from falling downwards, but when the weight becomes too much, or when it overcomes the force of vertical updrafts, then it has to naturally fall. Right. So, this is then you will see hailstorm in this area where the cloud is existing. Right. So, this is just an example of small hail event where the hail is even very small in size, the accumulation of small hail after a thunderstorm. The hail formed as supercooled cloud droplets collected on ice particles called graupel inside a cumulonimbus cloud. So, this is where, if these crystals are, let us say, kept in a vertical conducive updraft, they will grow into large sized hail crystals, right, let us say. So, this is the giant Caffeyville hailstone, which was almost like 1.67 pounds at a particular in the year 1970. So, this can be very dangerous. I mean, the size, if only one crystal, or if the hail contains hundreds and thousands of crystals which are at least of the size of, let us say, baseball, or even if it's a golf ball, then just imagine an object falling from the sky at an immense velocity of, let us say, 80 or 90 kilometers per hour. If it falls on something, it could be hazardous, right. So, hailstorms are very dangerous for various different forms of life that exist on the surface, right. The severe storms in 1888 was the most infamous hailstorm event, which nearly claimed 246 lives of humans, let us say, and 1600 cattle sheep in India, right. So, hailstorm is a very dangerous phenomena. Right. So, this was something about various forms of precipitation. So, we have already seen what is the condition for the formation of cloud and what happens when you say that cloud has formed, and what exactly is cloud, and when the cloud will be unstable and when it will rain, all this process. Then when it rains, we have seen how many different types of precipitation that this particular cloud can give us, right. So, we have seen precipitation in the forms of water, liquid water, and precipitation in the form of ice, various different forms of ice, right. So, we will stop here. So, we will continue this discussion and understand once there is rain, how do you measure it? I mean, what kind of unit or what kind of measuring equipment you will use to understand how much it has rained, right. Okay.